Hi guys, we're back with making math easy, and we're going to look at some examples of definite integrals. And definite integrals is this kind of integral. But what is an integral? To define an integral, if I could have some paper.
That's a paper.
So, to define an integral, it is an antiderivative with two types. This is our first integral video, and our first type that we're going to be looking at is definite integrals. An example of this is 1 with, say, 10 and -10. Alright, so what values lie with this? So, first of all, the formula says that given a function f of x, which would be 1, and then this integral would go something like this. Now, why? Well, so given a function f of x and a function big F of x, which is the x right here, where big F prime of x is equal to f of x, the definite integral of f of x is, given a certain value b and a of f of x, is equal to big F of x, those same numbers right here, which is equal to f of b minus f of a. And this means that in this case, f of x equals 1, big F of x equals x, f of b equals 10, and f of a, big F of a, equals -10. Applying this and b, by the way, is equal to 10, and a is equal to -10. These values are plugged into the formula to give us this. That is an example of a definite integral. Okay. So we're going to work with some quick examples here of a definite integral. Let's start with I don't know, 1 over 2 x to the 5th. So let's think of that. Over the value -7 and no. Over the value over the value 2 and 1. I don't want to get things too complicated here, because if we put I don't know, let's say a 56 something, it gets really complicated from there. You know what I mean? So that's why I'm just picking lower numbers. But if you want to use higher numbers, you probably want to take out a calculator because you might have to use really big exponents, like in this example. First of all, what do we know and what do we not know? Alright, so we know f of x is equal to 1/2 times x to the 5th. Big F of x, we don't know. Big F of A and big F of B, we're not supposed to know until we know at big F of x, so they're unknown. A is equal to 2. A is equal to 1 and B is equal to 2. So, when we think about that, we only have 3 given values. But with 3 given values, we can determine the other 3. There are 6 values, and we can determine the other 3 with just half of them. How? We need to work out the derivative of this function. So I'm going to go ahead and take some paper. And we're going to work this out.
What paper in it? You made it? Here?
I know. But we're going to work this out. Alright, first of all, we need to look for a value. Of course, it's going to be something enclosed in brackets with a 2 and a 1. So what we're going to think about is if we have 1/2 x to the 5th. Alright, so we want to think about it. What prime is equal to 1/2 x to the 5th? Alright, let's recall the general formula for differentiation. A times x to the n is equal to a times n times x to the n minus 1. Also, discovering the product rule says that if u and v, and I have a whole video about these formulas, if u and v are functions of x, and u prime and v prime are the derivatives of u and v respectively, then u times v all prime is equal to u prime times v plus u times v prime, and u over v all prime is equal to u prime times v minus u times v prime divided by v squared. We also have these formulas that say if u is a function if u is f of x and y equals u to the n, where u prime a times u to the n, where u prime is the derivative of u, where u prime is the derivative of u, then y prime is equal to a times n times u to the n minus 1 multiplied by u prime. And then, also, we have the formulas for trigonometric functions, exponents, like e to the x, and natural logarithms. And I'm going to put that up here because we don't have any more space. So, if u is f of x and u prime is the derivative of u, then sine of u all prime is equal to cosine of u. And I actually have these formulas down somewhere. Here, see? So, as you can see, sine of u prime is cosine of u. Cosine of u prime is equal to negative sine of u. Tangent... Oh, actually, no. Hold on. No. Not negative cosine of u, but... Look, hold on. So, it's equal to u prime times cosine of u. And negative u prime times sine of u. Tangent of u all prime is equal to u prime over cosine squared u. And so, with all that said, also, e to the u is equal to u prime times e to the u. And finally, ln of u is equal to u prime over u. Using these rules, how can we understand this? Well, some number, 5, we basically, to reverse it, it would have to be, if you have a times n, which is 1 half, and then you have n minus 1, which is 5, n would equal 6, which means that to find out a, it would have to be 1 half divided by 6, or 1 over 2 times 1 over 6, which is 1/12. Which means that it will be 1/12 times x to the 6th. Now that we have that, we know that big F of x is equal to 1/12 x to the 6th. So 1/12 x to the 6th. How do we find out these two? I said we're not allowed to find those until we find big F of x. Well, basically, you have to plug f of b in, which means 2 to the power of 6 is 64 divided by 12. So that's giving you 64 divided by 12 minus, and 64 divided by 12 can cancel down by 4 so far to 16 and 3. But that cannot be canceled down any further. So, that's 16 over 3. Then we plug in 1 in there, which obviously is 1/12. Which means that it would be 64 over 12 minus 1 over 12, or 63 over 12, which cannot cancel at all. So our ultimate result is the definite integral from 1 to 2 of 1 half times x to the 5th is equal to 63 over 12.